Hello, everyone, and thanks for joining the webinar today. Today, we're going to discuss how you can model decisions and validate them with data to deliver your projects on time. And I'm pleased that we have two special guests to present today, Pavle Ninkovic from Triple Consulting and Clive Riddle from MPI Europe. Before I get started, I'll just cover a few logistics. Your lines are muted for the webinar, so you'll need to use the chat window to ask questions. And we'll leave time at the end of the presentation for questions. My name is Colleen McClintock, and I'm Vice President of Products for Sparkling Logic.
Hi, I'm Pavle Ninkovic, and I'm a management consultant working in a small firm of consultants called Triple Consulting. Our work focuses on the intersection of banking, management, and IT. And because we spend a large part of our time helping banks implement and adapt to change, I'm interested in innovative methods and innovative technologies that help them do that. So in particular, I've explored the potential of decision models to exploit production data in order to improve requirements and reduce project timescales. I occasionally post articles on the How Banks Work industry blog, and that includes articles on this topic.
My name is Clive Riddle. I am a consultant with MPI Europe, which is a niche financial services consultancy based in the UK. Our main focus is on business process and technology projects that generally result from regulatory-driven and technology-enabled change. I've worked on a number of projects, essentially from tier one banks right down to smaller financial services firms.
So the problem we'll be covering today, modeling decisions and testing and validating the model with data, helps solve some of the issues with implementing regulatory requirements in software. And this can be a time-consuming and difficult process. And organizations such as banking and financial services, healthcare and insurance, organizations in these industries all struggle with this problem. And of course, regulatory compliance consists of a mix of processes, practices, and software implementation. And what we'll be looking at today applies to those regulations that are directly implemented in software. And the techniques we'll present today really apply more broadly. So these techniques can be used for any operational system that implements the logic to make a decision, primarily based on regulations, policies, or business best practices. So now I'm going to hand it over to Pavle, and he'll describe the approach.
Thanks, Colleen. This webinar will focus on three key and interrelated hypotheses. The first is that banks, and not just banks, other organizations as well, could make much greater use of all the data they hoard when they're defining requirements, and that using data to inform the requirements leads to a much better result. And we'll have a look at how in just a moment. The second hypothesis is that using a standard decision modeling notation helps to articulate testable requirements and generate test cases. Hypothesis 1 or 2 can be pursued as standalone ideas. Each can add some value. But our third hypothesis combines the first two and says that technology can be used to leverage the data from hypothesis 1 in order to validate the testable requirements captured in hypothesis 2, and that this is where the real value can be found. So let's now look at each of these ideas in turn. Typically, when we set out on a project, we tend to see the phases shown in this rather caricatured software development lifecycle. So first we define the requirements. We then hand those off to the software developers to turn them into code. And this may or may not involve an intermediary sort of description, such as a requirement specification document. But that's the basic idea. In parallel, we give the requirements to some testers to develop test scripts. The code and the test scripts eventually meet in the test phase, after which we'd hope to enter implementation. However, at this point in the test phase, we tend to discover some things. we discover firstly that our requirements contained some ambiguity, which meant our developers and our testers had to make certain assumptions. So for example, where a requirement talks about a large corporate, does that mean an organization with turnover greater than 20 million or an organization with more than 500 employees? Or if the requirement talks about working day, is this Monday to Friday, as in the UK, or Sunday to Thursday, as in the Emirates, for example? So this kind of ambiguity will generate some exceptions in test. Secondly, we discovered that there was a host of requirements that we just hadn't anticipated. For example, any payment submitted for execution on a UK bank holiday is handled differently to any other day. So the payment has to be held, or it gets rejected, or whatever it happens to be. But to think of every possible scenario when we're first writing the requirements is difficult. So rather than happily entering our implementation phase, we have these corner cases on the one hand, and the assumptions that need ironing out on the other, that cause us instead to return to the requirements and have to rework the code and redo the test cases and redo testing. Okay, so now can we implement? Well, typically this is the first time real production data is introduced to our software. Until now, we've used just dummy data or test data. And so here we have another point of painful realization that our assumptions about the data, about its availability, its completeness, its validity, weren't necessarily correct. And so often we have to do a load of data quality remediation at this point that inevitably make the project even later. There are two key points in this project lifecycle then, where we learn things that create more work and push the actual project completion date out to the right. Going back to our first hypothesis then, what we're saying is that if we can load the data somehow into the requirements definition phase of the project, we can bring forward a lot of that learning. We can detect data quality issues sooner and kick off the remediation work earlier. And we can also identify those missing or implicit requirements, the corner cases, because our production data would prompt us to think about them. So somewhere in our production data will be a payment dated for execution on a bank holiday. If we can do that, we can also achieve better test coverage with fewer exceptions in live, and we can avoid the need for lots of change requests late in the day. And if we can do that, if we can bring that learning forward and react to these things earlier, then we can avoid a lot of expensive and time-consuming rework, and we can shorten the project timescales. Let's now turn to decision modeling, and in particular an emerging industry standard called Decision Model and Notation, or DMN. This is a relatively recent addition to the OMG suite of industry standards. The Objects Management Group is the same industry body who manage other standards like Business Process Model and Notation, BPMN, and Unified Modeling Language, UML, among others. What this gives us is a standard set of pretty simple constructs to model decisions. The way it's often positioned is as the sister notation of BPMN. So business process models often include these diamond shapes in the process flow, and these represent gateways that control the downstream flow based on true or false, approve or decline, a yes or no sort of decision. Now, it's useful and valid to represent these in a business process, but that little diamond shape doesn't tell us very much about what happens in that decision. So it doesn't tell us anything about the inputs into the decision or about how we arrive at an outcome. On what basis do we decide whether we approve or decline this application, for example? Analysts sometimes attempt to add that level of detail to a business process model, but this tends to get pretty messy pretty quickly. So what they've done is disentangle the two ideas, decisions from processes, and came up with a standard dedicated to modeling decisions. There are two parts or two levels to the notation that I just want to cover briefly. The first is the visual representation of a decision and its dependencies. This is called a decision requirements graph, and in project management Prince2 terms, it reads a bit like a product breakdown structure. So the decision, the rectangle, requires some input data, which is the rounded shape. We also require some business knowledge, represented by the rectangles with the corners cut off. And this tells us what we need to do with the input data in order to arrive at an outcome. These are essentially the rules. And finally, this business knowledge comes from knowledge sources, represented by the document icons. And these might be your requirements documents or policy documents. It might be knowledgeable people, the subject matter experts in the organization, or it might be a governing industry body or some other authority for that knowledge. The second layer to DMN is the business logic, often captured in decision tables. These tell us, for a given combination of inputs in the blue columns, what is the output in the red column. So in the applicant risk rating example here, we can see that if an applicant is over 60 years old and has a good medical history, then they are assigned a medium risk rating. In fact, these rows with their input conditions and expected outcomes start to look a lot like test scripts. And so this already gives me the minimum number of scenarios that I'm going to have to cover in test. Today, many projects would articulate these kinds of decision-rich requirements in prose, in endless Word documents that our developers and testers would then have to work hard to interpret. The combination of decision requirements graphs and decision tables gives us a more concise and less ambiguous alternative to capturing these requirements. DMN also prompts us to think about the data already at this early design stage. It forces us to define our data input. And so, for example, if I think I'm going to need the medical history in order to work out the risk rating, am I confident that I have an attribute that tells me whether it's good or bad? If not, am I going to have to work it out based on some other information? Is there something else in my data, a combination of existing attributes, that I can use as a proxy, for example? So for the reasons we've already talked about, these are questions worth asking upfront. Now I'm going to hand over to Clive to introduce the case study we've chosen to test some of these theories on, and which we're going to model in the Sparkling tool.
Thank you, Pavle. Yes, as Pavle has explained, I'd just like to give you some context around this particular case study that we've put together in the Sparkling Logic tool to give you a little more understanding of how the Sparkling Logic tool has been applied in this particular instance. The European Deposit Guarantee Scheme is based around the securing of client deposits in banks within the compensation limits set by the regulation in the event of the bank default. Essentially, the majority of states have some rules in place, and this particular regulation is aimed at harmonising the 8,000 or so banks that are eligible across the region. We're going to look at two elements under the regulation. These are broken down into who is eligible, and if so, what compensation is payable. The main focus of the demonstration will be the eligibility element, which will be covered over the course of the next few slides.
Thanks, Clive. I should also add here that you might catch me using the terms EUDGS and FSCS interchangeably in this demo. FSCS just stands for the Financial Services Compensation Scheme and is the particular United Kingdom instance of the General European Directive. So how did we approach that first part of the question, is the account eligible? Well, when you get into the detail of the regulation, you find that rather than just the binary eligible, ineligible outcomes, an account can actually be marked in one of 8 different ways. When we started to model this using BPMN, the model quickly started to get difficult to follow. The thing to take from this model on this slide, besides the fact that it's messy, is that all the red boxes, except for the one in the top left, represent the 8 possible outcomes. So depending on the attributes of a given account, it ends up in one of these 8 buckets. Now, what does the model look like when we convert it into a decision requirements graph? Well, hopefully you'll agree it looks considerably simpler and cleaner. We have the top-level decision, how should the account be marked? And we can see it's dependent on a set of 4 other decisions. For example, is the account eligible by depositor? Is it eligible by deposit type, by geography, and should it be on the exclusions file? Obviously, all the decisions are also dependent on the account data, my input. And we also have a dependency on the consultation papers published by the Prudential Regulation Authority, the PRA. When we come to view this model in Sparkling, it should look a lot like this picture. But before we do that, Colleen will cover the high-level Sparkling systems architecture.
So this slide that you're looking at illustrates the high-level architecture of SMARTS Decision Manager and Pencil Decision Modeler. And SMARTS and Pencil are cloud-based products. They can also be deployed on-premise, but they're designed for the cloud, and they're accessed through a browser. Decision models that are defined in Pencil are stored in a decision repository, and you can open a decision model created with Pencil in SMARTS Decision Manager. So and once you open that project in SMARTS Decision Manager, you can generate an executable project where you can test and simulate your business rules and decisions. And when you're ready, you can deploy to a decision service that can be invoked from any process or system. So what you'll be seeing in the demo today is the Pencil Decision Modeler environment where you define decision models and business rules, and the SMARTS Decision Manager environment where you're able to introduce data so that you can test and execute your decision logic. So now I'll hand it back to Pavle for the demo.
Thanks, Colleen. So I'm just going to share my desktop at this stage. So hopefully now you can see in front of you Pencil and the decision requirements graph of the account marking model that we saw a moment ago. So here in Pencil we have the visual part of DMN rendered in the top part of the screen, and we have the business logic part displayed at the bottom part of the screen. And you can see that if I select the different decisions in the model, it filters the decision table for the one that supports that decision. So here, for example, if I expand this decision table for eligibility by depositor, it's a really simple example, and it just says if the depositor is a financial institution, a large corporate, a public authority, and so on, then the account is ineligible under the scheme, whereas if it's a natural person, a small business, etc., then the account is eligible under the scheme. Okay, so that's how we capture this in Pencil. We've kept things at a reasonably high level for the purposes of this demo, but I do have the option in Pencil of adding quite rich information about any of these elements. And so in particular, I want to show you the potential here to use that for the knowledge source. And in this example, we've linked the knowledge source, we've added a URL to the actual source document on the Bank of England website. But you also have the option of breaking it down to a more granular level of detail. So in this example, we have a couple of documents supporting the whole model, but there's no reason why we couldn't break this down into the individual sections of that document, and we could reference them using the fields available in the Properties tab here, and essentially create a separate knowledge source for each decision. And when you start to do that, essentially you start to create a very tight connection between the regulation, the requirements, through to your decisions, the logic, and the data. So I think this is a better way of documenting something that otherwise we'd document using very long Word documents or very long tables in Excel. What we've essentially done here is we've converted about 200 pages worth of regulation into a decision requirements graph and a set of decision tables that support it. The final thing I'd like to show you here before we move on to Smarts is the glossary. Anything I create in Pencil is automatically captured by Sparkling in this glossary. And this helps me keep track of all the concepts I introduce into my model. And I also have the option of arranging this information in various ways. So I can drag and drop category here and group things by category, which now allows me to quickly distinguish between my intermediate decisions, my overall decision, and my account information, for example. This is going to become particularly important when we come to validate this model with data in Smarts, because it's the glossary that allows me to map the data to the model. Right, so now let's open up this same project in Smarts. So you should now be able to see a different screen in front of you. This is the same account marking project we just saw, but it's being read in Smarts now from the shared repository that Colleen mentioned earlier. 3 elements are brought over from Pencil into Smarts. Firstly, on the left-hand side, we have the form, which is created on the back of that glossary, and it represents the various data fields and attributes that I'm going to use in my model. So it acts as a sort of template for my input data. The color coding just tells me whether an attribute is an input into a decision, and these are highlighted red, or if it's an outcome or an output of a decision, in which case it's highlighted in blue. And you'll see that some of them are highlighted in both blue and red, and these represent my intermediary decisions. And what's more, if I hover over any of these attributes, the hover text tells me how often that attribute is used in my rules. So for example, type of depositor here appears 8 times in my rules. The length of the highlight gives me a similar indication of the relative importance of each attribute in my rule set. Secondly, based on my decision tables, Smarts has read in the rules, which are rendered in the bottom right-hand corner of the screen. By default, these are represented in the Sparkle language, which is the language native to Smarts. But as we're going to see, there are other ways of viewing the rules. And thirdly and finally, we've brought in our decision flow. So let me expand that so we can see it more clearly. This is essentially based on my DRG, and if you look at it closely, you'll see that it's essentially an upside-down decision requirements graph. So this just ensures that the flow I defined in Pencil is respected when we run this model in Smarts. It also gives me a convenient way of navigating my rules, because as I select any decision, the rules in the bottom part of the screen filter for just those that are relevant to that decision. Okay, so let me just move this back now. And so now what we want to do is plug in some data into this model and use that to test the requirements. So the way we introduce the data into Smarts is pretty straightforward. I just need to navigate to the data part of my project, and I can drag and drop a file in here in order to load it. In this case, we have a JSON file. And I get a little confirmation message to tell me that it worked. And so now I've made the data in that file available for use in this particular project. So the data I want to use now is the mock modeling data, version 7. So let me go ahead and open that up. And so you'll see a change in the form now, where previously we had an empty template, we now have a populated account. And if I click through the different records here, you can see the values change. And you can see that we're looking at document 6 of 64. And this simply represents the 64 dummy accounts that we created for this demo in Excel and then loaded into Smarts. So obviously the thing we're most interested in now are the results of running these 64 accounts through the model. So this is where the dashboard feature comes in. So I'm going to hide the flow for the time being. So here I get an overview of how my 64 accounts are distributed across the 8 different outcomes, those 8 different buckets. And this is based on the rules that I defined in Pencil and the data that I just imported. So loading the data in this way into a model like this really brings it to life. Now, with the 64 perfect accounts we created in Excel for this demo, obviously this is going to work. In the real world, however, what would happen, for the reasons we've already talked about, is that I'd plug in my production data and I wouldn't get any results, or I'd get some odd results. So my model assumes some things about the data which are unlikely to be true. So in this particular example, the account we're looking at the moment, I have a deposit type which has a value laundered money. This is important because obviously we don't want to offer compensation for laundered money, and you can see that the eligibility by deposit type value is ineligible, and indeed the overall how should the account be marked, the value is ineligible for FSCS protection. In a bank, however, it's highly improbable that I have available such a convenient attribute in my systems. So if I fed my real data in here, all the rules trying to use deposit type simply wouldn't fire, and I'd immediately be able to see that manifest in the dashboard. Probably I would then have to go back to my SMEs and to my systems and ask, so how do we work out whether the money is laundered? Do we have an attribute in the system? Or are we going to have to concatenate a set of other flags and markers and so on to create a proxy for laundered money? Now, what happens if the rules change? So let's walk through a really simple example here. One of the features of the recast European Deposit Guarantee Scheme, which was published a couple of years ago, was actually a change in scope that included deposits made by large corporates, which were previously excluded. So where I have my rules concerning types of depositor, we're going to update them in order to see how the results change and see how my set of 64 accounts are impacted. So because I want to compare the before and after pictures here, I want to take a snapshot of the current results using this camera icon. And this is automatically timestamped. I can also add a little description. And so those results are now saved. So I can go ahead now and change my rule. Now to do that, I'm just going to change the display back to a table so that it's a bit easier to read. And so we can see here that large corporates appear in the conditions for ineligible. And so by clicking into the rule, I can take the large corporates out of the ineligible bucket and move them here into the eligible bucket. Okay, so having made that change now, what I want to do is rerun my data using the refresh button here. And in the dashboard now, I can see the before and after results side by side. So let me just maximize that so that it's a bit easier to read. And what I can see here is that in the bucket ineligible for FSCS protection, the number of accounts has dropped from 22 to 15. And those 7 accounts have been distributed across some of the other outcomes. So hopefully this demonstrates how, in a decision-rich and data-rich context, I can use a combination of Pencil and Smarts to quickly prototype my requirements into a live model and then run data through it, which gives me an opportunity to validate the requirements and the assumptions embedded in the model. And it also gives me an opportunity to learn some things about my data. And I can even use it to simulate different scenarios or maybe test our tolerances or what happens under different thresholds. So now let me hand back to Colleen, who is going to summarize.
Okay, and now we're going back to the slides. And to summarize what you've seen today, what we've shown you is how you can shorten your project timescales by modeling your decisions using DMN and then introducing data and validating them with real data. And really the benefit of this approach is that it really allows you to do a couple of things that shorten your project timescales. First of all, you'll be able to uncover data quality issues earlier in the project lifecycle, and you can also discover missing and implicit requirements. And the example that Pavle gave around laundered money is an example of perhaps a missing or implicit requirement. How would you detect that money was laundered? Also, using this approach provides a means to create test cases and ensure better test coverage so that you have fewer failures once you actually deploy. And this is because by modeling the decision, you have a testable a decision that you can begin to test earlier rather than later. And finally, by testing and discovering these problems earlier in the project, you'll have less rework from change requests. So that summarizes what we've shown today, and now I'd like to take the remaining time to answer any questions that you might have. So you can enter your questions in the chat window, and the chat window is on the left-hand side of the screen, and you can just go ahead and take a moment to enter those. And while you're entering your questions, I'll just invite you to, if you have any need for any business problems that we could solve that are business challenges that could benefit from the techniques that we discussed today, you can contact Triple Consulting at info@tripleconsulting.com. And also, I'd like to invite you to sign up for a free trial of Sparkling Logic. And you can find the trial sign up on our website at www.sparklinglogic.com. So we're starting to get a few questions in, so now I'll just take a moment to go over those questions. And the first question is each decision an executable rule set under the covers? So each decision in a decision model translates into a decision step when you open it in SMARTS. And a decision step is one of the nodes in the rule flow. Within a decision step, you have your executable rules. So the answer is that's exactly what happens. The decision table rules that you capture in Pencil, and by the way, you can also, Pavle didn't show this, but you can also document those rules as just simple text rules. And when you bring that into SMARTS, you have the executable rule set translated into executable format. Of course, to do that in Pencil, you need to use certain techniques to describe the decision table, certain constructs that will be executable in SMARTS. So your expression, what's called the expression language, has to be consistent with SMARTS. If it isn't, you'll still be able to open the project in SMARTS, and those comments that you made, if you captured them, for example, in natural language, would be represented, but you would have some errors to clean up once you got into SMARTS. So the second question is, in SMARTS, do we execute the rules using the READY-based engine? So for those of you who don't know, the READY-based engine is an engine that executes rules in an approach that allows you to execute whenever the data changes. So the READY engine is a very efficient algorithm when you have dynamically rules that update other fields in order to arrive at a decision, sort of these intermediate values, and especially if those are changing on the fly while the decision is being made. So this is called forward chaining in rule engine speak, and we have two modes available in Sparkling Logic. You can use the READY mode for certain decisions that require that kind of dynamic update, but the default engine is a sequential engine. But both are available, and in fact, the READY engine that we include in the product is the latest version of the READY engine by Charles Forgy, and Sparkling Logic is the only vendor that has access to that high-performance engine. So another question, what data formats can be imported into SMARTS, and can SMARTS access external data? And the answer is you can import, the way you saw Pavle import data, you can import a CSV, XML, and JSON files into SMARTS directly. And one of the things that you can do that he didn't show is you can also create test cases either directly in the product by creating a new document and populating those fields, or copying an additional document and just updating the fields that you need to create the test case. Or you can export to a CSV file and create your test cases in Excel and then re-import that into SMARTS. So it's a very convenient tool to manually create test cases. Also, you can access external data for testing and simulation, and this is through web services. So you have to set this up in SMARTS via HTTPS or FTPS, and you're able to access external data that resides within your organization without importing actual files. So that is also possible, and of course that data is for development purposes, development, testing, and simulation. And the next question is, can you export the rules from SMARTS or Pencil? And the answer is yes. Both SMARTS and Pencil can create an HTML report that includes the decision and all the associated rules so that they can be shared outside the project. So if SMARTS and Pencil are both collaborative tools and allow multiple users to work in the same projects at the same time, but if you need to share those rules in a documentation form with project stakeholders who perhaps don't have access to the tool, you're able to do that via the reporting capability in the tools. And the next question is it entirely a cloud-based model, or do we also support executing decisions in the cloud or on-premise in a process mode? So the answer is the products were both designed for the cloud, but they can be deployed on-premise, and many of our large customers choose this option for data security reasons and so forth. And the on-premise model is the products are delivered as a fully configured virtual appliance that you install into your virtualization environment. So there is an on-premise solution that many large customers choose as opposed to executing in the cloud. Some customers use a hybrid model. It's possible to do your decision development in the cloud and then deploy on-premise. So the answer is yes, both are supported. And then I think I have time to go ahead and do one more question. Does the project synchronize changes made in SMARTS back to the decision model in Pencil? And the answer is no, it does not synchronize. If you make a change in SMARTS, it's not synchronized back to Pencil. And this is primarily because the decision model is meant to be a high-level business representation for decisions. And it's possible to go down to the executable level, as you saw with what Pavle did in specifying all of the rules and actually bringing something over that's executable into SMARTS. But oftentimes, once you get into the execution phase, the executable decision will need to contain additional decision logic and rules that have to do with things like specific sequencing or data manipulation or other technical requirements that aren't actually related to the business decision logic. So there's some separation that is intentional between the two products. And most customers use Pencil to do their initial discovery and documentation for their decision logic. And then when they reach a point where they're ready to begin testing, they generate the executable project in SMARTS and introduce data and start to refine and uncover implicit requirements, data problems, and so forth. And after deployment, they may also use Pencil to initiate business-driven changes from the decision model that's represented in Pencil to the executable project in SMARTS, so that those changes in the next release can be tested prior to deployment using the updated business requirements. And then one final question, do we support versions of decision models and rules? And the answer is yes. Both SMARTS and Pencil create versions of the decisions and rule artifacts when you save the project. So you're able to, while you're working in the products, you're able to actually make changes and test them and experiment with them, and you're not persisting to the repository until you explicitly request a save. And when you do save, when you actually save the project, you are given the opportunity to document the purpose of those changes so that you'll be able to make sense of the different versions that you see that have been saved in the repository. So that is all the questions I'm going to take today. And if we didn't have time to answer your question, if you're, for example, some of you are still typing. So if we didn't get to your question, we'll follow up via email. And also, if you think of other questions, feel free to contact us and we'll be more than happy to answer. And finally, once we end the webinar, we'd really appreciate it if you just take a moment to complete the short survey. And thanks very much for joining today.